Okay, so now on this one right here, we're starting off with, this is going to be, what did I say, hashtag 69? So in my interactive notebook, this is going to be page 69. So this is going to be page 69 there. So today's date, what is today? So the 5th? So 11/5/19. So for you guys, a lot of people are not actually putting stuff in the notebook or updating your table of contents. So I'm doing my best to try and help you if you write everything out. Now, if you look at what we have here, it says notice and wonder. This is iterations. It goes way back to what we did at the very beginning of this semester, very beginning of the school year. I thought I had a red pen too. Yes, I do. Okay. So for this, iteration, it means that term of this, where number of total triangles added. So right here we added 0 triangles. We added 0 triangles there. So what I'm going to do is I'm going to show you what's being added now. So we added to my original this triangle right here, this triangle right here, and this triangle right here. So my original one didn't have any triangles added, so no triangles added, but my first one has 3 triangles added. So from here I have 3 triangles added. Now when I do this again, I will have those same triangles, which are over here in blue, but I'm also adding to every single one of the sides, I'm adding another triangle. So it's going to look like this. So every single one, so every side, I'm adding more. So every single side, I'm adding more. So each one of these so let's see. So the first one has 3. Total number of triangles added. I have 3 here. Now I'm going to do it again, but this next one is going to be all my ones in red. So I did my first, which was 3, but then I also added the red ones, which is going to be, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's where I get my 12. So 3 times 4 is 12. And then I have my 3 that I started off with, which gives me my total of 15. Yes?
Yeah.
Okay. So this next one, which goes along with this one right here, so I would do the same thing. So my pattern goes as such. So I'm not going to draw this one for this because, yeah, it'd make super tiny. It would be the third iteration would be 3 plus 3 times 4, which gave me this, plus 3 times 4 squared. So this item is going to be squared. So when we actually were doing the problem, it goes back to what we were doing way at the very beginning, which I had some a value times some r value and to the power of n minus 1. So going like that. Do you remember that way back? Yeah, a little bit. You don't have to remember it exactly. I'm just saying, you know, a little bit, just somewhat familiar. Somewhat familiar. So now we're going to do another one that goes along looking like this. So on this one right here, it said geometric addition formula. Earlier we learned that the nth term of geometric sequence with an initial value of A and a common ratio of R is right here. We learned this back in Unit 1. For a coach snowflake, it turns out that we could find the number of triangles added each iteration by having A being 3, R being 4, the sum S. That means S is going to be the sum of all those. Okay, there's also a nice symbol, sum. Okay, you guys will use that, on occasion. When you get to college, you'll notice that a lot more. You have to use it in Excel spreadsheets if you guys took any basic math classes. So the sum of this is going to be 3, which is my first one, right? Plus 3 times 4, plus as it keeps going on. Sum of the first n terms in geometric sequence tells us how many triangles total make up the nth term of the snowflake. That's where we get right here. So if you notice, there's an A plus A times R plus A times R squared. Now, as it keeps going on, A is a common factor. Now, this goes along. So if A is in everything and A is multiplying by everything, I could divide everything by A. So it would look like this. So if I take out an A from everything, I remove A from this piece, but it's still out here. Does that make sense or no? Not at all. Okay. Don't worry about the explanation. I'm going to explain the math here in a minute. Okay, the math actually does make sense on this. So, like I said, it's a long, complicated way of saying something kind of basic. So, what would happen if we multiplied each side of the equation by 1 minus r? So, it would be s 1 minus r, and it would be equals... Okay, sorry. Yeah, it was actually getting really hot in here earlier. Okay, so it's going to be a quantity, 1 minus r, and then it's going to be times... So I'm not going to multiply the whole thing. I'm not going to multiply the whole thing, because if I multiply the whole thing, is it kind of blurry or is it me? Okay, is that better? Yeah, go ahead. So I'm not going to go all the way to the nth term. I'm just going to go, let's go to the 5th. Or let's make it to the 4th. I'll make this one a little bit easier. So we're going to do this to the 4th. Because if I go all the way here, it'd be a whole bunch, and it's pointless to actually do that much multiplication. So 1 plus r squared plus r cubed plus r4. So this term right here says that it just keeps going on to whichever term minus 1. So I'm going to scooch this up a little bit. Now, we're going to do the multiplication, and we're going to do the box method. Box method in the polynomial multiplication, you guys actually were doing pretty good on that. So hopefully that works out a little bit better. So instead of the distribution, because distribution people are struggling with still, 1 right here and negative r right there. So box method. So on top, since this is multiplication, all these terms right here are going to go on top. 1, r squared, r cubed, and r to the 4th. All right, 1 times 1. 1 times negative r. Negative r. R times 1. Very good. R times negative r. Very good. So negative r squared. R squared times 1. R squared, right? So now r squared times negative r. Cubed, very good. R cubed times 1. R cubed. R cubed times negative r. Fourth, very good. R to the 4th times 1. And r to the 4 times negative r. Negative r to the 5th, very good. Now, let's go through and I'm going to point a couple things out. So to write out my answer, it's going to be 1. There's my first term, right? Now, what happens to my r's? And I get what? They cancel, right? So I have a negative r and a positive r that cancels. What about r squared? They cancel. R cubes. R fourth. Okay, and that leaves me with r to the 5th. Negative r to the 5th. All right, this is what we did the other day. Hey, George, if you want to come up here, there's space up here. Right over there. Okay, right next to Terrence. That's a lot closer. So we have this value right here. So this is when I distributed this, but I cannot forget that a value, right? I cannot forget the a value. So I'm going to put the a value outside. So I cannot forget that. And that's still going to be equal to all of this over here, right? Yes. Yeah. So that's equal to S 1 minus R. Now the next part is the piece that it actually, everything applies. So all the math and everything actually goes along with this next part. So if you're still having trouble with all this, this is where we get all this information from. So if I wanted to get r by itself, what would I do to the 1 minus r? Not add, this is a multiplication, isn't it? I'm going to divide both sides by 1 minus r. So if I divide both sides by 1 minus r, it's going to be S is equal to a quantity 1 minus r to the 5th power, right? Over 1 minus r. Now, there's a reason why I took it to the 5th. If I took it to the, like this one said, n minus 1, that wouldn't be nice. Okay, it would be a whole lot of multiplication and canceling. All right, so basically what I'm trying to tell you is this is going to end up becoming, so if I was looking for the 5th term, it would look like this. If I was looking for the 5th term, it would look like this. So this would be S of my 5. So this is going to be my formula. So here's my new formula, which is super important. Super important. S is equal to A, which is my A value, which is my initial value. That's how much we're starting off with. Parentheses, 1 minus R to the N value. Divided by 1 minus R. So, watch. I'll even box this to show you how important it is. That little piece right there is going to help you with everything. 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 Everything.
So that's the formula?
That is it. So, let's see if y'all paying attention.
So n minus 1 is a pain, so we should do this instead.
All this right here, yes, is a super pain, right? So all that stuff that we did back in the first unit to eventually get to that form, okay, we could just do it as polynomial, as a sum from here. So, long way about it. This is the part that we should have just started off with. Anyway, so use this formula to calculate how many triangles after the original are in the first 5, 10, and 15. All right. Let's go back. So this is my Koch snowflake. What was the A value for the snowflake problem? 3. Look, it's even up here. Look, it's 3. Right there, look. 3. So super important right there. So it's going to be S is equal to 3, right? Parentheses. 1 minus 4, because that's my R value, right? And what power am I using? 5. I'm using 5 because that's going to be my first one right here, right? 5, close, divided by 1 minus 4. All right, so listen up. This is what you're doing. In your handy-dandy calculator, you're going to make sure you get this correct. Because as soon as you get it, it's going to make life a whole lot easier. All right, let's see. Jonathan, what'd you get for that first one? What'd you get for this one? Yes, you're putting it in the calculator. Yes, you were taking a nap, so that's why I'm... Okay, but did you put it in the calculator? Not yet, right?
Is it negative?
Nope, it's positive.
It was 1023.
1023.
I didn't get that.
30, 70.
Okay, so give me one moment and I will pull up my calculator to try to show you guys. Okay, does your calculation look exactly like this? Do you have the parentheses where they go? Okay, it has to look exactly like this. So take a look at it, see if it looks exactly like this. So entering stuff in the calculator is probably one of the most crucial skills.
Like, I swear it's exactly the same.
I swear.
Is it divided by 1 minus 4?
Yeah, it's over. So I'm gonna do the
Like, how do you do it?
yeah, control, divide, 3,
Oh, that's why mine's spelled the same. Alright.
okay, parentheses, 1 minus 4 raised to the 5th, right? Over 1 minus 4. 1023? 1023. Everybody got 1023?
You just weren't working it in or what?
No, not really. I'm not using the smart part of the board anymore. I'm just using the projector. So, yeah. Okay, so we got that. Now, let's take a look at the next part. So, the next one says to do what? 10. So, if I'm going to do 10, yep, S equals, shh, please, 3, parentheses, 1 minus 4 to the 10, close, over, 1 minus 4. Okay, I know. Should be a big number.
1048,575.
Oh, yeah.
What is it?
1048, 1048,575.
There we go, right?
Right?
Yeah.
$1,048,575.
Oh, shoot.
Okay, so what's the next one?
15.
15. So if you remember how to use the calculator correctly, what could you do to make this a whole lot easier?
Go up to the equation and press enter.
Yep, just go up to the equation, press enter, and it'll actually bring you a copy of the equation down and change it to 15, right?
I got the number.
It's a big
107.
Give me 1 second. Give me 1 second. Okay, so I know it's a billion, so it's 1. 418 what?
23.
I wish my bank account looked like that.
Right.
It does, but in the negative. $1 billion.
Like 6
I'm at 3 figures. Not 4.
Woo! 3 figures. Not bad. You know what? I remember back in the day, the first time I actually had personally made my own money and made it over 2 figures. I was all excited.
Just 2 figures? I'm just saying.
You're at 3 figures now, right?
Because I spend a lot of money.
Okay, so yeah. So when I finally got excited, I made it past that point.
I don't got a job though.
Okay.
figures though.
I want to be able to make 8 figures.
8 figures?
8 figures zeros.
That reminds me of
You're
Cardi
seeing
B.
the
When I
thing
hear
like-
figures, it
He said
reminds me
clown.
of-
Okay. So did everyone get this one?
No.
No?
That's 10 figures.
No.
JK.
JK? No. Yeah, it is. Fifth lunch. Okay. All right, let's take a look at this next one over here, please. Okay. Backside. Han. Okay, so Mr. Solo is prescribed a course of antibiotics for an infection. He is told to take 150 milligram dose of antibiotic regularly every 12 hours for 15 days. Okay? Says Han is curious about the antibiotic and learns that at the end of the 12 hours, only 5% of the dose is still in his body. Okay, 5%. Help me out. What is 5% as a fraction? That's a decimal. I agree. I agree. Now, I'm going to show you. So, that is correct as a decimal, but watch this. Okay, shh. The word percent. What does cent mean? Cent means 100, right? So the word percent, by definition, is out of 100. So if it's 5%, it's 5 over 100. So my initial amount is going to be letter A. So what is A going to be here? Nope. 150. Thank you. My initial amount is 150. So the R value in this case, 5 over 100, right? Now, if you were to write that as a decimal, it would be 0.05. So 0.05, that's very good. Okay, so now we have to do a couple things here.
12 hours.
Yep, if it's every 12 hours, how many do you take each day? 2 a day. So after 15 days, how many doses? D-O... How do you spell dose?
DOSE.
S-E. I know it's on here somewhere. Oh, there it is. Is 30, right? So my dose is equal to 30. So how much of the antibiotics is in the body after the first dose. Okay, so first dose. First dose is going to be what? Nope.
5.
No, yeah,
10.
no, 55.
150.
Oh, yeah.
Did you just take a dose?
No. The whole thing.
Yes, you took the whole thing, right? Now, by the time you take the second dose, did you still have some left over from the first one?
Yes.
You have a yes.
Well, how come he has 5 but
30 minus 50.
Okay, so watch this. He's still going to have a little bit. So on the time he takes that second pill, he's going to have how much of the first one left over?
5%?
He has 5% of the first one left over. So it's going to be 150 times 5 out of 100. Because he had some left over from the first time. Yes? He had a little bit left over from the first time. Okay. But now because I keep increasing this every time. So there's going to be a larger amount every time I go and take the pill again. Because it's no longer the 150, it's going to be 150 plus whatever I had, right? And so every time I do that, I have to increase my value by the previous amount also. Okay, so watch this. So the next one's going to be 150 times 5 over 100 squared. Because I did it once right here, right? So I got this previous value. Yes. I had this previous value here, which is still part of my first value that I took in. So there's still a little bit in. So by doses, my first value is going to be 150. Now, the second dose is going to be 150 plus this. So can you tell me what this is going to be then? What? Someone just went. Yes, Josh, when Josh gets back. So this value right here is going to be, for the second dose, we're adding the 150 plus this, which is going to be, I know y'all calculating right now.
7.5.
Yep, so it's 7.5. So my full thing,
How you get that?
did you calculate this? Yes,
Just that.
this is 7.5. So, but he took another pill, didn't he? So it's the 150 plus what's left over, which is going to be 157.5. So when I take the second dose, I had some left over from the first. So it's 157.5. Okay. So now, on this next one, I'm sorry, on the third dose is going to look like this. So it's going to be all of these, right, plus this third one, right? So that's going to give me
My computer give me a fraction.
put control, enter. Did it give you 3/8 or something like that, right?
Okay, I got it.
Okay. So the third time it's going to be all three of these, right? Okay. It's school lunch. They're not going to be jealous of it.
It's Nuggies.
Is it Nuggets?
Yeah.
Oh. Shh. No, I'm recording this lesson.
Oh,
So yeah.
Nuggies are the best.
Okay, so there's my first, there's my second, there's my third. Now, let's go to the next question. Hey, shh. No. When will the total amount of the antibiotic in hand be the highest over the course of the 15-day treatment? So, does it go up every time we take a dose?
Yes.
It does go up every time I take a dose. So if it goes up every time I take a dose, then when is it going to be the largest?
What is 15?
At 15 days, right? But what dose is that? It's the 30th because you take a pill twice a day, right? So at the end, so you take a pill twice a day, so you have to actually plug it in for 30. So now let's do the full formula. So my total, which would be like the S, would equal A quantity 1 minus R to the N over 1 minus R, right? So I'm going to have
Mister, what is that by the R?
N. There's your N, right? So my A value here is, what's the A? The initial amount is 150. 150 parentheses 1 minus, what is my R? 5 over 100, right? 5 over 100. And what power is that going to be raised to?
30.
30, very good. Close over,
1 minus 5 over
yes, 1 minus 5 over 100. So control divide 150 open 1 minus 5 over 100 to the 30th power. All this is going to be over 1 minus 5 over 100. And see this nasty thing right here? The calculator tries to give you a decimal or a fraction all the time. So all we have to do is go Control, Enter. So after the 30th day, it's going to be 157 point, let's say 895.
Yeah, that's something way.
Okay, look at your equation. Look at your equation. Look at what you put in the calculator.
Yeah.
When you push, when you get that big
I
number.
got 33.8.
Me too.
I got 33.8903. I don't know if it's because you put parentheses over the 5.
You got it, because otherwise you're only going to take the 5 to the 30th.
So you got, so look at mine.
Ugh.
Okay, you don't, it's a parentheses 1 minus 5 over 100 parentheses to the 30 power. I don't have a parentheses over the 5 over 100. Which I should have had, right?
Yes, because you're taking the whole thing to the 30th power. Okay, we only need to take the 5 over 100 to the 30th.
Just because of that specific
Yeah.
problem, it messes it up.
I know, and that's why we're practicing in the calculator.
Excuse me, sir, where did you say to press?
Control divide for your
Oh, control divide, okay.
control divide is going to give you a fraction. Okay.
Okay, thank you so much.
I don't answer it. I still got, wait, hold up. This is what I did. I did it.
Okay, so where's that now?
I had just put it in the right way.
Hold on. I'm going to modify this, okay? So you have to
I
do
just
this.
did that. I just did it. You do it?
Hold on. Because you're different. Yeah, you're up. So you were up too high, so that means that it wasn't letting me change that. There you go. were on the wrong one. So you were up too high. You were up like 2 levels.
So
And
I have the,
you're missing your bodies. All this right here is still supposed to be over something.
so in the equation,
Oh, over this?
Yeah, it's over the bottom of it, which is
Sure.
the 1. Yes.
in the formula, shouldn't we, put the parentheses on R then?
You can, but no matter what it is, the 5 over 100, that's the value that's being raised to the power.
Okay, so should we always put parentheses in the power that's being raised?
I would do it. If you notice right here, I did do it on this. All right. Do you guys see that? I did do it right here. So this is my parentheses. My parentheses, so I'm only going to raise this number to the 30th power. All right, you guys, so now, takeaway from this one is, what do you need to actually do this lesson? Calculator. So I'm going to give you the rest of the time. Don't forget, like, share, and subscribe.